Hi, this is Charles Campbell. I'm a professor at the University of Washington. I just wanted to introduce you briefly to the research in our group. To do that I'm going to share screen and a PowerPoint presentation that's brief. The subject of our group's research is on transition metal catalysts and electrocatalysts for clean energy technologies, and we aim towards fundamental understanding of that and elucidating pathways to catalysts design, improved catalyst design. These catalysts typically are in the form of late transition metal nanoparticles, in this case silver, on some support material. One of the things our group has become famous for is showing that the energetics of the metal atoms and the adsorbed intermediates on the surfaces of these nanoparticles of metal are crucial. And the energetics of metal atoms depend on the size of the nanoparticles and the support material to which the metal is attached. And that controls the stability of the metal atoms, which then determines the strength by which the metal atoms bond both to the catalytic reaction intermediates and to the catalyst material. The binding to the catalyst material determines the long-term stability of the catalyst under reaction conditions, which is crucial, and the binding strength to the reaction intermediates is crucial for determining how fast the reaction rate proceeds on that catalyst material. Here, for example, is the energy diagram for all the elementary steps involved in this methane reaction that produces hydrogen from methane. And different catalyst materials bind these intermediates in the reaction and the transition states with different energies. And it's really those different energies that determine the difference in the reaction rates on one catalyst and selectivities on one catalyst versus another. And so those are crucial. Nowadays, most of those energy diagrams are produced from density functional theory, but it's crucial also to measure those. And our group has done more of that than anyone else in the world experimentally. So all of these very simple adsorbed molecular fragments are ubiquitous intermediates in all sorts of clean energy technology reactions, both catalytic and electrocatalytic, but their energies were just not known until the measurements in our group from anything except for theory. And one of the things we found is that density functional theory, which is state-of-the-art computation, is actually quite inaccurate for some of these species. So it's guiding, our measurements are guiding developments of new theories for that. The instrumentation is complex for these things, but it is also quite doable. Here's two recent people from the group. Spencer Carey, who's got his PhD here, is now a postdoc in Germany at the famous Fritz Haber Institute. And Wei Zhao was a postdoc here and is now a professor in China. So thank you for your attention, and I will stop.